When we look into an empty room, our intuition tells us we are looking at a void, a passive, featureless stage waiting for matter. Building the rules of the universe on the assumption of true emptiness has forced theoretical physics into a corner. To make equations balance, scientists have repeatedly had to inject arbitrary numbers into their mathematical models. This chart shows the scale of the cosmological constant problem. The towering bar represents the theoretical prediction of quantum vacuum energy, while the tiny sliver at the bottom is the actual density of dark energy observed. The math predicts an energy level roughly 120 orders of magnitude larger. Then we have the particle origin problem. The standard model treats fundamental particles as infinitely small points that carry specific masses, yet no core theory can explain where these exact mass numbers come from, treating them essentially as random properties floating in a void. These massive mathematical mismatches suggest that the failures of the standard model aren't just errors in calculation, but clues that space itself possesses an underlying architecture defined by physical boundaries. To find this architecture, we have to look at the entire universe as a single object at the macroscopic extreme. The first rule of this geometry relies on the Cosmic Casimir Hypothesis. This framework suggests that the massive quantum energy prediction we saw earlier belongs to an infinite, unbounded parent vacuum existing outside of our own cosmos. Our cosmos acts as a closed cavity filter, blocking chaotic energy and allowing only a tiny residual pressure inside. Based on this pressure, physicists derived a cavity radius of 51 billion light-years. For context, our observable universe is 46.5 billion light-years. The missing 120 orders of magnitude of dark energy appears to be the mathematical signature of the physical boundary enclosing our cosmos. The outer boundary filters energy, but the internal structure dictates its behavior. Let's drop from the cosmic edge down to the subatomic scale. Here, the unified mechanics of vibration models the vacuum as a rigid, crystalline acoustic medium. It acts as a continuous physical grid carrying mechanical waves. Particles form when pressure waves collide, locking into stable topological knots. The electron is a torus knot. Its 720-degree loop physically replicates spin 1/2 behavior. Conversely, a muon decays rapidly because its unstable shape bleeds acoustic energy back into the vacuum. Matter itself is localized harmonic resonance, trapped within the acoustic geometry of the vacuum. Because this lattice is a discrete structure, these waves can only settle into stable configurations at specific intervals. This identifies prime numbers as the foundational resonant nodes, dictating exactly where energy can and cannot cluster. Using prime number acoustic resonances, we can calculate the proton-to-electron mass ratio by combining a tri-stable vortex node with a fractional vacuum drag variable. The geometry outputs exactly 1836.152731. This matches the established empirical codata target to 99.99997%. The mass of fundamental particles appears to be a deterministic niproduct of prime number geometry operating in the vacuum. To find the final limit of this system, we push our scale to the absolute bottom of the universe, the Planck limit. Here we encounter spatial crystallization. As a wave's frequency hits the Planck limit, its peaks align exactly with the vacuum lattice. Unable to oscillate faster than this grid, forward velocity drops to zero. The energy freezes into standing waves, creating a hard quantum ceiling. From the cosmic boundary filtering dark energy to the subatomic lattice dictating electron mass, these geometric boundaries determine the rules of our reality.